Example 1.9. 2-point charges Q1 and Q2 of magnitude 10 to the power minus 8 coulomb and minus 10 to the power minus 8 coulomb respectively are placed 0.1 meter apart. Calculate the field at point A, B and C as shown. Yes, first we'll try to realize the question. Two equal and opposite charges are given. In other words, dipole is given. What is the electric field along the axial line of the dipole, along the equatorial line of the dipole, and at the center of the dipole? Okay. First thing, expression for electric field equal to KQ by R square. If electric field, two electric fields acting on the same direction, we are adding. If they are acting in a different direction, we are subtracting. Now, first point, electric field at point A. Where is point A? Here, at the center of the dipole. Whenever we have to find out electric field, at that point, we are keeping 1 coulomb of charge and we are calculating force. So, I kept 1 coulomb here. Now, electric field E1 equal to KQ by R square. This is plus Q. So, Q value 10 to the power minus 8. This separation is 0.05 whole square. So, you are getting answer 3.6 into 10 to the power 4. What's the direction? Direction is towards right. Now, let us take the minus charge. When you are taking the minus charge, this is plus, it will attract towards minus charge. So, there is no change in the magnitude. Direction also, it is always towards right here. In other words, total field E equal to E1 plus E2, that is 3.6 plus 3.6 into 10 to the power 4. Answer is 7.2 into 10 to the power 4 Newton per coulomb. And its direction is towards right. Now, we'll go to next case. That is electric field at point B. Where is your point B? Along the axial line. Here, if you are able to recall the formula, directly you can write 2 kpr divided by r square minus a square whole square. If not, again we will do step by step. Selected point is B, right? First we will find out electric field due to Q2. Q2 is negative. Here plus 1 coulomb charge. So it will attract towards plus Q. Electric field is towards right. That is given by KQ divided by R square. R square value 0.05, 0.05, 0.05. If you add, it becomes 0.15. But here, no need to take the negative sign because we are showing in the direction. Direction is towards right. Then, what is the electric field? This here 1 coulomb, here it is minus. So, it is attracting. Now, come to this point. Plus Q is there. Here also 1 Q. These two will show the repulsion. So, towards left it will come now. That value is KQ by R square. Therefore, that is same as 3.2 into 10 to the power 4 at Newton per coulomb. So, one field is acting towards left, another field is acting towards right. Now, we'll compare which is more 3.6 into 10 to the power 4 acting towards left, but 4 into 10 to the power 3 acting towards right. So, first we'll make the same power. 10 to the power 3, if you multiply by 10, it becomes 36. So, 36 is greater than 4. The resultant field is 3.6 10 to the power 4 minus 4 into 10 to the power 3. That becomes 3.2 into 10 to the power 4. As that towards left, the field is more. So, the net field is towards left. Now, we'll go to last case. That is at point C. C lies along equatorial line. Here also you can use the formula directly. If not, you can do one by one. Field at C due to charge Q, that is equal to KQ by R square. R value is given as 0.1 KQ by R square. And field due to Q2 is also same, but direction is different. This is negative. It is attracting downward, but here it is repelling downward. But these two electric fields are equal. Therefore, the resultant field E equal to component of EX and EY. If you are taking this one E1 and this as E2, you have to take the component. Or in short, you can say 2E cos 60 because total angle is 120. Bisector becomes 60, 60. Because of bisector, why it is because of bisector? Because both the sides are equal. This electric field equal to this electric field. So the resultant equal to 2e cos 60. Cos 60 equal to half. So you are getting the answer 9 into 10 to the power 3. Direction is towards right or positive to negative.